Now, let's go over. I'm going to have to get some new markers today. The last day of class is equal to, for y'all, Tuesday, April 21st. I will cover material until April 21st. I don't know why it's not supposed to be. Okay? The last test, which will be called the Unit 4 test, will cover material up to April 21st. Okay, so there's three things about the next couple of weeks of class. Okay? And that marker is dead. The Unit 4 test and the final exam will start on April 22nd, if not sooner. Okay? So, and will last until midnight, April 28th. So you have this whole week to finish the Unit 4 test, which is called the last test, and the final exam. Okay? The final exam well, let me just write it on the next page. The final exam will cover whatever we've covered this semester. Unit 1, Unit 2, Unit 3, and whatever we cover on Unit 4. To review your test, as I showed y'all at the beginning of the semester, you go to Gradebook, you pull up which test you want, and you hit the review link. Okay, so the final exam will cover those units. It will be 2 attempts. Usually 25 or 33 questions. I usually hang around those unless I go above it, and if I do, it'd be 40, and that's it. I don't usually do anything different than 25, 33, or 40. And, of course, you have 2 hours to take, which is not, you're not going to use all that 2 hours unless you just go back and check work all the 2 hours. And that's pretty much the final exam. Now remember, the final exam is 20% of your grade. Now, mathematically, we have 5 tests, so all of your test is 20%. And your homework is 20%, and this comes out to be your final exam 20%, and the rest is 60%. So that's what it comes out to be pretty much. So if you want to find out your final grade, you go to Gradebook. After you have finished everything, after you have completed all your work, you hit overall grade. And whatever that overall grade is, that is your grade for the semester. So I want to go over this again. Last day of class is Tuesday, April 21st. I will cover material until April 21st. The last test, which is called the Unit 4 test, will cover material up to April 21st. The Unit 4 test and the final exam both will start on April 22nd and close on April 28th. The final exam will consist of all the material that I've covered, Unit 1 through Unit 4. You will have 2 attempts to take the test. Let me shut this off because I don't want to lag. 25 to 33 questions and 2 hours to take the test. And of course, with the 2 attempts, it takes the highest grade. Now, the reason I'm going over this twice, I'm doing this in all my classes, so I won't get a bunch of DA emails asking about this. Okay? Grade book. When you've completed all your assignments, hit the overall grade, and that's the grade that I'm going to see to put in Tri-County Tech's record. Now, since Ms. McCann, you're the only one here this morning, do you have any questions about this?
No, sir. Seems pretty straightforward.
Straightforward, isn't it? I'll get at least, out of this class, I'll get at least 5 or 6 emails.
So you will not be going over like you have with our other tests.
No, because you've got your unit test to use, and you know what the test looks like. Yeah, the final exam is nothing but a big unit 1 through 4 test. That's all it is. So if you study your Unit 1 through Unit 4 test, and you know what I like, you know what I stress. You know there's going to be a question on there about mean, median, mode, range, mid-range, standard deviation, variance. You know that's going to be on there. You know that odds against is going to be on there. You know that the probability of a king is going to be on there. You know the highlights. What I put on my test, that's what I put on the final exam. I don't put A, B, and C on my unit test and then put D, E, and F on the final exam. I don't do that. That's what some other teachers do. I don't do that. I put whatever's on my test. So when I go through and I pick the problem, I pick them directly off the test and I drag them over to the final exam. So that's how I do it. Okay? All right.
Alrighty.
So that takes care of that. I've covered that. So the Math 120-10 and the Math 120-23 all have directions for the next 2 weeks in class. Although I'm going to go over it in the 120-23 tomorrow, I'm going to put both of these up because I don't want no DA questions. When's the final? I have no idea. All right, now I'm going to kind of go through 8.1 and 8.2 and hit the hot spots. What I mean the hot spots, I'm going to cover what will be on the exam or what will be on the test. I'm not going to go through and cover, because I really want to get to chapter 9 and 10. Because 8.1 and 8.2 is kind of a, I don't know, it's not really, it's relevant, but not very relevant. So 9.1 and 9.2 is a whole lot more relevant. Sample mean, you know what the sample mean is. Normal population, non-normal population. Statistics such as X bar are random variables since their value varies sample to sample. As such, they have probability distributions associated with them. In this chapter, we focus on the shape, center, and spread of statistics such as the mean. Okay, you don't have to write that down. Sampling distribution of a statistic is a probability distribution for all possible values of the statistic computed from the sample size n. A sampling distribution of the sample mean, X bar, is the probability distribution of the possible values. Okay, they're going over stuff that we've already been over. So X bar computed from a sample size n from a population with mean and standard deviation. Compute the sample mean, assuming that we are sampling from a finite population until all distinct random samples of size. Okay, they're talking about doing, yeah. Okay, yeah, that's why I don't cover this very. The weights of pennies minted after 1982, you can write this question down, are approximately distributed with a mean of 2.46 and a standard deviation of 0.02. Approximate the sampling distribution of the sample mean by obtaining 200 random samples of size n is equal to 5 from its population. Now, they're saying the weights of pennies minted, okay, they've got a population. This is a population mean and standard deviation. Okay, so you'd put population beside this because it says the weights of pennies minted after 1982. There's not 200 or 300. It says the weights of pennies, all pennies, after 1982 are approximately blah, 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 blah. Approximate the sampling distribution of the sample mean by obtaining 200 pennies and pick sample sizes of 5 from this population. That's what it's saying, and I'm not going to do all that. But they're going to give you a bunch of pennies on the next. Okay, there's 1, 2, 3, 4, 5 pennies right there. For example, the first sample, take out of that 200 pennies, you pick 5. And you write their weights down, and then you find the average. So they're finding, okay, let me go back. You've got the population mean and standard deviation right here. And then you go into 200 pennies and you pick 5 and you look at the mean for those 5. There's 2.44 and the population mean is 2.46. So you see in that the 2.44 is comparing to the 2.46. And here's different sample means. There should be, if you take 5, how many times will 5 go into 200? 100 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's your 100 means. Okay. Sample size n is equal to 5. They've done several different variations. Okay, so they threw the 5 back in and picked another 5. I don't know why they're doing so many. The mean of 200 of 200. That's why the mean of 200 means is 2.46, the same as the mean of the population. So they took all of those means right there, and they averaged them up, and they got 2.46 being the same as the population mean. The standard deviation of the sample mean is 0.0086, which is smaller than the standard deviation of the population. And there's the weights, and you see that it's pretty normal. Okay, this is just information. It's not really that big a deal. I haven't, so far there's nothing testable I've given you. I'm not, when I get to a testable part, I'll tell you. This is just information. What role does N, the sample size, play in the standard deviation of the distribution of the sample mean? As the size of the sample increases, this is your large number rule, as the size of the sample increases, the standard deviation of the distribution of the sample mean decreases. So you might want to write that down just as general. So as the size of the sample increases, the standard deviation decreases. That's not testable, but it's just something you might want to put in your brain housing group. And they go through this, and I'm not going to go through all that again because they're basically testing it up against 2.46 and 0.02, and I'm not going to go through all that because I'm not going to test you on it. I'm trying to get, okay, now write this down for later. The mean and standard deviation of the sampling distribution. Suppose that a simple random sample of size n is drawn from a large population with mean and a standard deviation. The sampling distribution of x bar will have a mean blank and a standard deviation of sigma over square root of n. Now you're going to see this later in chapter 9, so you might want to write that down. And what they're talking about is they're saying if I give you a mean and a standard deviation of a sample, and then I say, what would happen if you pick 6 more blah, blah, blah? What would the mean and sample deviation be? And that's where this comes in. Okay? I would put the square root of 6 right here because I said 6 more. And the standard deviation, that comes from right there. So the new standard deviation would be standard deviation over the square root of 6. You'll see in just a minute. Hopefully they'll give us a... In chapter 9, I know they give us one, but this chapter 8 is kind of a filler. Chapter 8.1 and 8.2, it kind of prepares you in a round the world sort of way for what we're going to do in chapter 9, but it goes way around the world. Because right now we haven't done anything that's testable. Except for that one thing right there. That's the only thing that you're going to be tested on later in chapter 9, is that right there. Let's go back. The weights of pennies minted after 1982 are approximately normally distributed. Okay, this is a sample. Remember when I told you 6? Well, what is the probability that 10 pennies minted after we obtain a sample mean of at least 2.46? What is the probability that in a simple random sample of 10, after we've read this, we get 10 pennies after 1982, we obtain a sample mean of at least 2.46 grams. Okay, so there's that 10. That square root of 10 is going to be in the formula using this right there. So it's going to have my sample standard deviation over the square root of 10. So write that question down. Now you're going to see a different application of this in chapter 9, but the whole premise of it is that you're going to plug that 10 into the square root symbol, into the radicand. Tell me when you get through writing those 2 little paragraphs down, please. But again, this is not 8.1 and 8.2. So far I haven't seen anything testable. but you will see that square root of n, and you'll see this in chapter 9, but it'll be a different question. And make sure nobody else is Skyping in while you're writing that down. And I'm going to cut class short today. When's the test due? Is it due? Is it already due or?
It's due tonight.
Okay. I'm going to cut class short because I know students are still getting that test done and you've worked your tail off, so there ain't no sense in. I just don't want to put too much on today with new material and people doing the test. So I think we're going to cut class at 9 o'clock today.
Alrighty.
Besides, we're not far from the end anyway. I'm looking to see.
I finished writing, just to let you know.
I'm sorry, what?
I finished writing.
Okay. All right, today is the 9th. We got till the 21st, which is a couple more weeks. So we're okay. All right. So, and what they're going to do is they're going to plug that 10 into the square root symbol. And there it is. Okay? So write that down, because what they're saying is the probability, this is kind of like a new z-score. All right? So there's 2.465. It's like the z-score. Okay? Because the mean is 2.46 and the standard deviation, the previous standard deviation, hold on, is 0.02. Okay? So they're plugging it in, and there's that 0.0063, and 1 minus, and they're finding the right-hand side. So you would type in your calculator, since you have a newer calculator, you would type in 2.465 to 9999 normal CDF, and you would get that area right there. They did the 1 minus because that 0.7852 is over here, and you minus it because their calculator don't have a right tail, so it doesn't tell you, you can't do. So that's all. That's why you got the complement in there. Okay. So that's how this works right here. And the only thing, as I teach every semester, you're going to see this in chapter 9. So I'll let you finish writing that down with the bell curve so you can see. And make sure that 2148 is with the blue area. And you type it in on your calculator. Remind me, do you have a newer calculator or an older calculator?
I have a newer calculator.
Okay, so you would type in mu is equal to 2.46, and the standard deviation is 0.0063. And you would type in 2.465 to 9999, and it would give you that 2.2148. You don't have to, though, because we're not gonna do this right now.
I got it all down.
Okay. And I'm not going through this because this is not relevant. Okay, this one says estimate the sample distribution of X bar by obtaining 200 simple random samples of size n is equal to 4. So instead of 5, you're going to pull up 4, whatever we got. And calculating the sample mean for each of the 200 samples, repeat the n is equal to 10 and 30 histograms, and they're just going to show you what they did. This is not testable, so I'm not going to, they're just showing you what the means look like. And this is the key points of 8.12, the formula right there. That's what I told you before. Okay? The shape of the distribution of the sample mean becomes approximately normal as the sample size, what? Increases. That's your large number rule. The more you do, the better. And that formula right there, that's the key points from example for this section, really. So you might want to write down that again, and right here, the shape of the sample means becomes normal as the sample size n increases. Okay? The central limit theorem. Regardless of the shape of the underlying population, and you might want to write this down just for knowledge. Regardless of the shape of the underlying population, the sampling distribution of X bar becomes approximately normal as the sample size increases. That's the central limit theorem. Oops, sorry. And you might want to write that down because that could be a definition on a standardized test. Let me know when you get through. So I might limit the 8.1 and 8.2 homework depending on what I think is important. So I wouldn't start working on the 8.1 and 8.2 homework yet, okay?
Okay, so just hold off? Just
hold off until Monday or Tuesday next week, because I don't, unless I see something real pushing right now, I'll probably just start you off on 9.1 homework. Because a lot of this, you remember in chapter 1 and 2, I told you to read a lot? Well,
yes, sir.
That's a lot of what this is. You finished? Did you finish writing that?
Yes, sir.
Okay. And you see, again, you see them, they had 35, there's your new n, and you plug it in right there. So, again, they're showing you that that new standard deviation is going to be based on the new n that they give you. So here's an example, and you can write it down. It says, suppose that the mean time for an oil change is 10 minutes is 11.4 minutes with a standard deviation of 3.2. What if you had a sample of 35? Well, then you put the 35 right there, and that's your new standard deviation. Now, this is a good example because it shows you how the central limit theorem works. Basically, they give you a mean and standard deviation, and then they say, what if? Okay? You got a population mean and standard deviation right here. Then they say, what if you have a sample of 35 oil changes? This is a good example for you to write down and use as an example. And there it is. The new standard deviation, instead of 3.2, now it's 0.54, which is almost a minute. You don't have to write down word for word. Just say, what if a random sample of N35 oil changes is selected?
Got it.
Okay. So that's a good example for a standardized test question. And if I was going to test you on anything in chapter 8.1, this would be the kind of question, this would be the kind of question I would ask you. I give you a mean and a standard deviation, and then I say, what if? And then that 35, what if, that what if number right here will go right there, and that'll give you a new standard deviation on the 35. And then what do you do with that? Well, you change the z-score into a new z-score by using that new standard deviation. Now this is testable. These two, A and B, is testable. So we're starting to get into a little bit of it now. All right, so there's your new standard deviation. So you put that new standard deviation into your z-score formula. 11 minus 11.4 over is equal to negative 0.74. So that is your new z-score. If a random sample of n is equal to 34, what is the probability? 0.2300. I wish they would put 4 digits because that looks like a z-score. 0.2300. So what is less than 11 minutes? So now with those extra 35, with that sample mean of 35 oil changes, you've got a probability now of 23%, 0.2300 being less than 11 minutes. Oops, I'm sorry. So let me go back and try something. We know, and I'm going to draw this. Let me pull up my .4 and 3.2. 11.4 I need you to calculate 11.4 plus, what was it, 3.2? So add 3.2 on the right, and that's going to be what, 14.6, 17.8, and 30.21. You check me.
That is correct.
All right, and then 11.4 minus 3.2, 8.2 minus 3.2 will be 5, and minus 3.2 is 1.8. All right, now that's what you've been learning all semester. So in this problem, this right here, you've learned this all semester. Oh, I didn't know you could move that. You've learned that all semester. Now, A says, what if, so I'm going to put A up in the top left-hand corner here. I'm going to try to use this to guide me, and I'm just going to write. Okay, it says, what if a random sample of 35 oil changes? What if, and I say what if because that's the difference between the questions we're doing now and the questions we had before. The questions we had before is right here, okay? And you draw the bell curve. Now it's saying, what if n is equal to 35? What if you picked 35 oil changes after you got this information? What if you took a random sample of 35 oil changes? What would it do? What would your probability of a oil change being less than 11 minutes? Okay? And they're getting you ready for chapter 9 is what they're getting you ready for, because that's where we start, chapter 10, where we start getting into hypothesis testing. Okay? So let me move that over because I don't know if you can see there. Okay, so this right here is old stuff. This right here is the new stuff. What if 35? Well, then you go over here and you say, well, 3.2, I think that's 3.2 over the square root of 35. 3.2 over the square root of 35, which is equal to 0.5409. 0.5409. And that technically is your new standard deviation. That's your new standard deviation. What does the new standard deviation do? Well, that's the next slide. The new standard deviation gives you a new z-score. Okay? An adjusted z-score. So you need to put right here, adjusted z-score is equal to 11 minus 11.4, because you're doing 11 minutes, okay? All right? So 11 would be right in here. 11 would be right in there somewhere. But you don't want the 11, you want the z-score. So there's the 11 right there. So you adjust the z-score and you say 11 minus over the new standard deviation, which is right there. I'm trying to go back and forth, which is right there, and that's going to be 0.5409, which you should have used in the previous, in chapter 7 and 6, you would have, or 7, you would have used 3.2 right here. So that's the difference between what we're doing here. And that comes out to be negative 0.74. And that's about negative 0.74 with this negative 1 right here, negative 2, negative 3. Negative 0.74 would move it right about here. And that is your new, based on 35, new z-score, not based on the population, but based on 35 random samples. And what is the area under that? And they say it's 0.2300. So this right here, that dotted line right there, is based on 35 random sample without you having to go back and redo everything. You just have to get a new z-score based on that new standard deviation. So that's what's new, okay? So that's an okay example. This is an okay example as far as something, and that's 8.1. So they went around the world to show you one problem. Told you it was and there's the one problem right there. That, and what actually new did you do? You just got a new z-score using that 0.5409 instead of 3.2. That's it. That's the only thing testable right there out of 8.1 is that problem right there. So make sure you got that problem down. Okay? Now, in 8.2, we're starting to get into some more good stuff. We're starting to get into some stuff that we're going to be using. And this is it. Write this down. You write the whole thing down. You don't have to write down word for word. But this is called p-hat. P-hat, you're going to use a good bit in chapter 9 and 10. Suppose that a random sample size n is obtained from a population in which individual either does or does not have a certain characteristic. A sample proportion, and I'm going to write this down. Sample proportion sample proportion means sample fraction is equal to p-hat. That's all p-hat is equal to the x, which is the smaller number, over n, which is always your what? Biggest number. sample proportion. Therefore, Q hat is the complement. Q hat is equal to 1 minus P hat. And you might just want to put that over to the side. We don't have it on here. So just write down sample proportion. This is what's important in 8.2. Now, I may ask you some questions on this in the test. The only question I'm going to ask you in 8.1 is that last slide. Okay? Now, on 8.2, I'm going to start asking you questions about P hat. I want you to be able to find P hat out of A, and they're going to give you an example, so it's not a big deal. And make sure that you understand that Q hat is the complement of P hat. So whatever P hat is, subtract it from 1 and you get Q hat. Here's an example. There it is. There's your example. So write it down because I will give you a question about 8.2 on the test because it's important that you understand what P hat is. In a Quinnipiac is very, very notorious, very, very well known in the statistical world. Quinnipiac poll is a very high up there poll. Conducted in May 2008, 1,745 registered voters nationwide were asked if they approved of the way W is handling the economy. 349 responded yes. 349 responded yes. So therefore, P hat is equal to 349 over 1745. How did I know that? Because 1745 is your biggest number. Oh, and it's written right there too. And that's P hat. So Q hat, and I'm writing, so that's P hat is equal, what was it, point what? Oh, 0.2. Therefore, Q hat is equal to 0.8. So make sure you understand that because you're going to see this later. Tell me when you get caught up because I don't know what kind of lag we got.
I've got it.
Okay. Okay, they're doing sample sizes, and they're doing mean, standard deviation. They're using simulations. I'm not gonna do that. Okay, write this down. It's not a big deal, but it might ask you on a standardized test. As the size of N increases, the shape of the sampling distribution becomes approximately normal. And I think that's what they were trying to show you right here. See, that looks somewhat normal. That looks a little bit better normal. And then, of course, that looks like a normal curve. And that's what they're trying to show you. As N increases, the shape of the sampling distribution of the sample proportion becomes approximately normal. And if the shape is normal, then the center starts to be more defined. Okay? The mean of the sample distribution of the sample equals the proportion. So it starts to, as you start to see the normal bell curve, if you start to see it start to materialize or get more defined, so does the center. And then you can compare the spread. The spread here is a whole lot smaller than the spread here. And I don't know why they're telling you that in Chapter 8. We've already discussed that in Unit 1. But anyway. Okay, here is another good slide. if you want to find the standard deviation of p hat, and you need to check to make sure right here, I'm sorry, the model of the previous slide requires that the sampled values are independent. When sampling from a finite population, this assumption is verified by checking that the sample size n is no more than 5% of the population size. So n has to be less than 5% of big N. So write that down. Little n has to be less than or equal to 0.05, there's that nickel rule, 5% of big N. And they'll give you an example. And NPQ is greater than 10. Okay? The mean of the sample distribution and standard is this. So write that down. The standard deviation p hat equals PQ over N, square root. You're going to see that again. So you might want to write that one down. PQ over N, square root. PQ over N. And I promise you in chapter 9, this is going to start making sense because they're going to start using this stuff and you're going to see how they're using it. Right now, they're just going around the world to tell you how to do something. That's why I'm trying to go through these. I'm skipping some stuff in here because it's not relevant. When it's relevant, that's when it starts getting in chapter 9. You got that formula written down? 3 formulas.
Yes, sir.
Okay, that one, make sure you say big N, little n has to be less than 5% of big N. NPQ greater than 10, greater than or equal to 10. And then standard deviation of p hat is equal to PQ over N square root. All right. And I think they're giving you an example here. According to a time poll conducted in June of 2008, 42%, that's 0.42, of registered voters believe that gay and lesbian couples should be allowed to marry. Suppose that we obtain a simple random sample of 50 voters and determine which voters believe that gay and lesbian couples should be allowed to marry. Describe the sampling distribution of the sample proportion for registered voters who believe that blah, 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 blah. Okay, so you got some numbers in here. Your numbers are 42%, which is P, because that's not P hat. P hat is when you have a number over a number, and then it turns into P because 0.42. But, and 50. So, 50, the sample of N is smaller than 5% of the population size. Think of the population of all registered voters in the United States. Well, there's 350 million people in the United States. How many registered voters you think is going to be? If it was half, that would be what? 175 million? Okay, 5% of 175 million is going to be greater than 50. Okay, or 50 times 0.5. That you ain't got to worry about that. Also, NPQ, 50 times 0.42 times 0.58 is equal to 12. 12 is greater. So write this down because this is a little test that you do before you take the standard deviation. And then you take PQ and divide by 50 and take the square root, and that is your new standard deviation. This is very close to the standard deviation of 0.072 found using simulation in example 2. So that's the little test that they're going to, and you will see this again in chapter 9 and 10. You're going to see this test. So make sure that you write, especially that first sentence, because they're assuming that you know there's 350 million people in the United States. Let's see, I don't know how many registered voters there are in the United States. Let's look that up while you're writing that down. Registered voters in U.S. And of course, it doesn't tell you. You gotta, how many number of registered voters in the United States in 2018. I said 175 million, 153 million. All right, so take, 5% of 153 million. Well, 10% would be 153,000, something like that. I can't, and that'd be a whole lot. You ain't got to worry about that first test. The second test, NPQ, has got to be greater than or equal to 10, and it is. And then PQ over N, square root, is 0.06. You got that? And again, you're going to see it later because I'm going to say, remember when we did this in Chapter 8? And that's it. That's the 3 tests right there. Not 3 tests. 2 tests, and then finding the standard deviation. Compute probabilities of a sample proportion according to the Centers of Disease Control and Prevention. 18.8% of school-age children. That's my sign. Okay, we're going to cut it off after this one. Okay, so 18.8, that's P. So Q would be, that's 19%. So Q would be like 81%. So just telling you, we're over 8. In a random sample of 90 school-age children aged 6 to 11, what is the probability that at least 19% are overweight? Suppose a random sample of 90 school children aged 6 to 11 results in 24 overweight children. There 24 is going to be N. What might you conclude? And I'll wait till you write that down. Okay, you can throw out the 6 to 11 because that doesn't help you. The 18.8 is P. Q would be, I don't forget what I said, 81.2. Yeah, 81.2, I believe it would be. 19% are overweight, at least 19%. So let me know when you get finished. I didn't know these were down here. Can I write on this? I didn't know I could write on this. Oh my gosh, look at there. Wow. Learn something new. I didn't know I could do that. Now I don't know how to get my cursor back.
You have a work email.
All right. First of all, N is equal to 90 is less than 5% of the population size. Most of the time, that's going to be true.
You have a work email.
Now take NPQ, 90 times 0.18 times what I say, 0.8812. I think that's what I got. Is equal to 13.7. That's above 10. So there's test number 1. There's test number 2. Now you can find the standard deviation. P hat is approximately normal with a mean of 0.0188. Okay? And standard deviation of NP over N. I'm sorry, PQ over N. And there's your new standard deviation. So there's your point 19 minus 18.8. That's what you were given. Equals 0.0 over z, and that's your z-score. And then you just check above your z-score of 0.05. And of course, if you have a calculator that does the right-hand side, you would do 0.05 to 9999 because it's a what? It's greater than. So that would be 0.05 to 9999, which should be that number right there. This is old calculator. That's if you have an old calculator. Okay? If you have a new calculator, you do 0.05 to 9999, and you should get that 0.4801. And we'll do some more of this come chapter 9 and 10. All right, that's a good stopping point. I don't even know how many we got left in the, let's see how many we got left. That's it. So I just went over 8.2 pretty much. Okay, we'll finish 8.2. We'll finish that last slide Tuesday. All right, all I want you to do this weekend, and that's for you as well as the 23 and the rest of the 12010 class, I just want you to take the weekend off, finish your test. When's the test due?
Tonight.
Tonight. Finish the test tonight. Have the weekend off. If you want to read 8.1 and 8.2, read over it. And maybe read 9.1 and 9.2 because that's what we're going to start with after I finish this last. Because basically that's, I'm going to leave that on there. I'm going to leave this one on the video so you can write the rest of that one down. And that's it.
Alright.
Okay? So I went through 8.1 and 8.2 kind of fast, but don't worry about it. I don't want you to worry about doing the homework for 8.1 and 8.2. I want you to take the weekend off. I want you to read 8.1 and 8.2, 9.1 and 9.2. And then when y'all come back Tuesday, we will start 9.1, and you're going to see all of this stuff in 8.1 and 8.2 come out in 9.1 and 9.2. So just be patient with me. I don't even know if I'm going to do the 8.1 and 8.2 homework. I'm going to look at it and see what they ask you. They can't ask you too much in 8.1 because it's not a lot of material. So I'm going to have to look over 8.1 and 8.2 to make sure that it's even feasible homework. Do you understand?
Yes, sir.
All right. So I'm going to shut her down and